Sahlan. Okay, Assalamualaikum warahmatullahi wabarakatuh, and good morning to all of you. So everyone can hear me, isn't it?
Yes, doctor.
Yes,
Okay,
doctor.
great. Okay, great. So before we begin with the lecture, I just want to remind you about the attendance. Okay, so basically, if you refer back to the CI course information, there is one statement that state you are not allowed to enter final examination if your attendance is less than 80%. Okay, so if your attendance less than 80%, I will not allow you to attend a final exam. Okay, make sure that you are aware about this. Okay, this is the regulation from UTM. Okay, I don't think that this is not serious. Sorry, this is thing that you have to make it serious. Okay, all right. It is not only for this subject, this course, but for all courses in UTM. Okay, make sure that you aware about this. All right. So we do have a record for that. If someone that we found that not attending the class, so we will take action lah. Okay. All right. This is the regulation. So I have to follow the regulation. This is my responsibility. All right. So announcement for today, as we agree that every Sunday at 9 a.m. we will have a tutorial class, and the tutorial class will be discussing on the exercise, of course, not the lecture lah. Okay, so we do exercise on the tutorial, but before we discuss the solution during the tutorial class, so I emphasize this thing. Okay, so you have to do exercises. You have to do by your own first. Okay, maybe you can discuss with your friend. Maybe you can get the information from the internet, for example. Get the maybe solution if you can find the solution from the internet sources, from the book, for example. Okay, regarding the exercise. Okay, you have to do the exercise from the book that I suggest you. Some of you already purchased. Okay, and then during the time, during the tutorial time, I will pick a name and the student should be able to explain the solution in front of the class, okay, online. Okay, and then the question is, since next week is our test one, so I emphasis on the lecture on the particle resultant 2D and also equilibrium 2D. So you have to do the exercise. Okay, for the resultant 2D, is the number of exercise that you have to do. Top 2.6, 2.7, 2.20, 2.21, 2.25, 2.27, and 2.28. And then for the particle equilibrium 2D, so you have to do this one, 3.6 and so on. Okay, so let me check the book.
Doctor,
Yes. Yeah.
is the session for this tutorial class will be recorded?
Yeah, of course, I will record the tutorial class as well, and will upload the recorded video in e-learning.
Okay, thank you. And also the question, questions?
Okay, this question is actually you can get it from book. If you don't purchase the book, I think you have to get it from someone that already purchased the book. Okay, maybe someone can screenshot the question and post it in the WhatsApp group. Okay.
Okay, doctor, thank you.
Okay. So any volunteer, you can post it the question in the WhatsApp group so everyone can get it, especially those who are not purchasing the book. Okay, so yes, we will discuss the solution during the class. I believe that we cannot cover all questions in 1 hour, in our 1 hour tutorial, but we will pick 1 or 2 questions, or maybe 3 questions from the exercise, and we can discuss it in the class. Okay, and also I will only provide the final answer only. Okay, for the solution you have to practice. Okay, I will provide the final answer only. Okay, this is the only things that I want to announce to you. Okay, so yes, since we have a tutorial class, so I just proceed with the lecture about the exercise, about the example. Maybe we can discuss in the tutorial class. Okay, so we proceed for the next lecture, lecture 5, which is rigid bodies. Okay, moment in 2D. So last class we have learned about moment 2D. Okay, moment 2D. So this time around we will learn moment 3D. So what you will learn for today is the first thing is a moment of a force about a point in 3D. Okay. Number 2, maybe not today. Okay, maybe next week. Okay, you will learn on moment of a force about an axis in 3D. Okay, so in 3D we do have an axis as well, because we can find the moment about an axis. But in 2D we only have one, which is a moment of force about a point. Okay, in 3D we do have two different type of moment. Okay, one is about a point, another one is about an axis. Okay, so an axis we do have two different important things that you will learn. The first one is you can find the angle between two vectors. Okay, so we do have axis, we do have the moment, so you can find the angle between those two. Okay, and the nearest distance between two vectors. Okay, and of course you have to learn the example and do the exercises later on. Okay, all right, so this is the thing that you will learn for today. Okay, we will only cover the vector identity of cross product. Okay, so this is a moment of a force about a point D. So recap back about the mathematics. This one is mathematics. Okay, so if you have two vectors, okay, you have two vectors product. Okay, let's say P and Q, and there is one angle between those two vectors, which is theta. Okay, and according to right hand rule, okay, from mathematics, so we do have this equation actually for cross product. Okay, P cross Q equal to PQ sine theta, and Q cross P equal to PQ sine theta as well, but in different direction. Okay, if the P cross Q is a negative product or negative sign, but for the Q cross P must be positive direction. Okay, so you have to aware about this as well, where P cross Q is not same, is not equivalent to Q cross P. Okay, it is not same. Okay, so because of the direction, of course, negative and positive product. Okay, so if you can see the right hand rule here, okay, if you remember, we learn about this thumb rule of right hand rule like this. Okay, so we can say that this finger is representing the axis. Okay, this finger is representing the axis. Okay, this, and other 4 finger, 1 2 3 4 fingers, okay, representing the direction. Okay, representing the direction. Okay, so basically let me draw here. Okay, let's say this is your finger, this is my finger lah. Hah? Kita go in finger saya. Okay, let's say for example this is my 5 fingers. Okay, 5 fingers. Okay, according to right hand rule, we do have this one representing the axis, and this one, the 4 fingers representing the direction. So this is mathematics. Okay, I believe that you have learned this during secondary school or high school. Okay, so if you have these vectors P and Q, okay, and let's say I introduce one axis, which is, for example, Z axis lah. Okay, Z axis, and maybe I introduce more axis, X1, X and Y axis slightly, for example. Okay, for example, X and Y axis. Okay, so we know that X, Y axis can be converted into IJK form. So we can denote this as I, J, and K. Alright? Okay. So if you use right hand rule to get the moment, for example, okay, to get the moment, okay, you will see this one. Okay, let's say this is your mother finger, okay, and then the direction should be like this lah. Okay, you will get Q cross P. Okay, Q cross P, which is this one. Okay, and we assume that at the moment, at the beginning, that Q cross P is a positive key. Okay, right. So if you are trying to make it like this, where the Y, where the Z axis is downward. Okay, so you will have this vector, you will have this cross product. Okay, we can say negative K, because your direction of Z is negative Z. So that's why we get negative K. Okay, so you have to bear in mind that we always use right hand rules for the cross product, of course, right hand rules. Okay, this is only illustration for the PQ vectors. Okay, you will understand further if we do exercises later on. Okay, all right. So far so good, guys. Are you okay?
Yes. Okay, Doctor.
Right, great. So this is not very what do you call it? Not very difficult, because you have learned it before during your secondary or high school. Okay, let me proceed to the moment. Okay, this is the definition of moment about a point for the 3D. Okay, for the 3-dimensional. Okay, last class we learned 2D. 2D, the moment is equal to F times with distance, force time with distance. And this time for the 3D, okay, it is like not 100% similar, okay, but with different arrangement of vectors. Okay, so since we have a 3D, okay, we do have a position vector to indicate the position from where to where, from point A to point B. Okay, so the distance there in 3D, we representing as R. Okay, R, from where to where, from A to B. Okay, so we call it position vector. Okay, we call it position vector. Or some books, some cases, okay, some scholar said it for R is for the location vector. Okay, so location, from where to where. Okay, and some of the books, refer it to position vector. Okay, so R, position vector. Okay, if you can see here, R is starting point, where the point where moment is taken. Okay, so let's say you are calculating the moment about a point A. Okay, for example, A, then you have to start the point of R, okay, R, from A lah, for example, from A, and end of the point where the force act, where the end of point of R should be the force, either the initial point of force or maybe the final point of force. Okay, so maybe this is the thing that I have to draw. Okay, I have to draw. Let's say example, like very simple example like this. Or let's say we do have origin point here, O. Okay, and then we do have one force like this, for example. Okay, X, Y, Z, for example. Okay, so the R is actually from, okay, the R position vector is actually from the point where moment is taken here lah, 0. If we want to find a moment about point O lah, okay, all right, starting point here, and end point where the force at, the second thing, and where the point where the force at. So it come from the O, and it can be here, number 1, R1, for example. And you can maybe put the R in another distance, in another position or location from O to here, the starting point of force, R2, for example. Okay, this is your R. Okay, you cannot use both because yeah, in the end of the day you will get the same answer. The thing that I want to say is that you have to determine which simplest R that you will use for the calculation, for the solution. Later on I will tell about this during the example. Okay, so since this case is in 3D, so you have to resolve, you have to have R in term IJK form. So these are, okay, no longer in 2D last time. So you have to transform the R value into IJK form like this. Okay, so you have to consider X, Y, and Z value. Okay, and of course the force itself, since you have learned about the what do you call it, resultant, okay, resultant in 3D. So this force of F, okay, and you have to convert it into IJK form as shown in the slide. Okay, so using the scalar product, cross product. Okay, once you have these two value of R and F, okay, you substitute the value of R and F into the general equation, into the definition of moment equation, then you will have this one. Okay, all right, everything clear, guys?
Yes, Doctor.
Okay, so let's move to the next one. Okay, this one is mathematics. Okay, mathematics. We are not learning static. Okay, this is mathematics. Okay, this slide showing the mathematics. Okay, the static one is only for the equation R cross F. Okay, this is the static equation, but this one is mathematics. Okay, so I believe that you are already familiar with this, but then I have to explain. Okay, all right, in 3D analysis, R and F are resolved into X and Y, Z components. Okay, so since the cross product, we use sine theta. Okay, sine theta equal to 0 or 1. So sine theta, we do have two values. Okay, the first value is 0 and another value is 1. So 0 representing 0 degree, okay, or 180 degree for 1 value, for value of 1. Okay, so if you look at this, I can say table, for example, table, you can see the cross product between I and I equal to 0. Okay, I cross j equal to k. Okay, I cross k equal to minus j, I equal to negative k, and so on. Okay, do you still remember about this, or you need my explanation? Yeah, remember this. Okay? So no need to explain, eh? Okay, what about others? Hmm? Okay. So okay, all right. So but yes, I have to explain lah a bit. Okay, how we get positive K and negative J? So of course you have to use right hand rule as I said just now. Okay, so let's say your eye, your rule, sorry, your finger like this. Buruknya saya punya finger. So this is the axis, for example, this direction. Okay. So this one is 3D. Let's say I convert it into 2D like this. 1 point, 1 point, 1 point. Okay. From 1 point to another point, from 1 point to another point, from 1 point to another point. Okay. And let's say I put 1 point equal to, let me change the color. This point is I, for example. This point is J, for example. This one is K, for example. Okay. And this is the direction, which is like this lah. Let's say you are see the screen in 2D, the direction of Z towards to my body, towards to your body. Okay, so this is the direction. Okay, so you can use this arrow or this illustration to understand why we get negative, why we get positive. Okay, if you cross between I and J, okay, I cross J, you will get K, but positive value, because we are following the direction, okay, the initial direction, this arrow, red arrow. Okay, if you cross J and K, you will get I. Okay, this one. If you cross K and I, you will get this one, K cross I equal to J, positive. Okay, but for this case, if you cross opposite, I cross K, like this one, I cross K, we oppose the direction. Okay, so meaning that the answer is negative J lah. Same goes to J and I here. J cross I, you will get K, but in negative value. Same goes to K cross J, K cross J. Okay, opposite direction. Then you will get negative I. And for the I, JJ in KK, for sure it will be a 0. Okay, this is the cross product. Okay, so if you substitute the value of K in the negative or positive sign, you will get this one. Okay, you will get this one. Okay, but I have to mention that if you use this type of method, will be not disaster, but will be time consuming lah, of course. So again, before I introduce the next method, okay, which is determinant. So this is the basic one that I have to explain to you. So right hand rule. Okay, all right. So this is another method that you can solve the cross product. Okay, so we call it determinant. Okay, we call it determinant. Okay, so you can put the value, you can put the I, J, K, I like this. Okay, and put the value of R, X, Y, Z, X, Y again, and put the value of force in this orientation, okay, it will be easier for you to get the answer for cross product. Okay, So I believe that some of you maybe learn this during the high school. Okay, if you want to cross the product, okay, you will have to make it like this. Okay, all right. The answer for I component, X component, is the what do you call it? Cross between R and FZ, RY and FZ. Okay, you will get okay RZ, RY and FZ. You will get this one, and this one is positive. Okay, and for the J component, this one J component, okay, positive, still positive because we crossing R and F. Okay, R cross F X, R Z cross F X. So you will get this one. Okay, and the K component, okay, still positive, R X cross Fy, you will get this one. Okay, but the other thing is that this color, the yellow color, which is you have to be careful to crossing both of them. Okay, so since that we are crossing F R, okay, F cross R should be in negative value lah. The K component there here, but the value is F X R and should be negative because we are opposing the cross product. Same goes to the other one. Okay, I component. Okay, this one negative. Same goes to J component. This one will get this one, but in negative sign. Okay, so you rearrange again. You arrange the components into X component, Y component, and Z component, and the final one you will get moment. The answer for moment. Okay, all right. Everything clear? Everything is clear or not?
Yeah, Doctor.
Okay. So if clear, we proceed to the next one, which is example one. Okay, example one, very straightforward. Very straightforward. Okay. So this is the simple example. Okay. You have to determine the moment of force, 3,000 Newton here from point C to point D. Okay. And about point A. So point A is here. Okay. All right. So the idea is that you have to find R and F first in terms of IJK form. Then you can do the cross product. Okay, the second question is that you have to determine the shorter distance between point A and the line of action of the force. Okay, so the idea is you have to find the D lah for the second question. Okay, D is the line of action. Line of action from A to D, from A to this line of action. For example, I assuming this is the shorter distance. Okay, must be perpendicular in 3D. Okay, and D is the shorter distance, for example, D is the thing that you have to find, the shorter distance. Okay, all right. So from here, from the question here, you have to use the equation of M equal to FD. Okay, okay, I will show you in the solution. Right. Okay, so for the first question, okay, for the first question, you have to find moment. You have to find moment about point A. Okay, so this point, this force, okay, in this direction, okay, you have to convert it into IJK form. Okay, so my question is, you have learned about you have learned three methods before. So for this case, which method that you have to use to calculate the force in terms of IJK form?
Coordinate.
Yes, correct.
Coordinate method.
Yeah, coordinate method. All right. So you will get the IJK. Okay. The detail of solution will be explained in the next slide. So this is the only idea, brainstorming the idea first. Okay. Then using this equation, okay, M equal to R cross F. Okay. So you have to find R. So R, like I said just now, R is from the point to the line of action. The point to the force act. Okay, the point where it start from the moment taken and finish at the force act. Okay, this one. So in this case, the starting point should be from A because we are calculating moment about point A, and the R having two different direction position. Okay, the first one is from A to C. Let's say I put it RAC. Okay, and the second one is from A to D. Let's say I put it RAD. Okay, so you will get RAC and RAD. Okay, so you will choose either one later for the calculation of moment. Okay, this is the idea. This is the idea. Okay, so this is the solution. Okay, using the equation of moment about point A. Okay, so as you mentioned that we will use coordinate system, coordinate method. Okay, to find the f in terms of IJK form. Okay, you will have dx, dy, and dz. Okay, and dz is negative value 0.4 because it's coming from right to left. Okay, in x direction. That's why we get it. We get a 0.4 in negative value. So for the dy, because it's coming from upper to down, then we will get -2. And for the z is coming from the back to front. Okay, we will get 2.2. Yeah. So substitute all information of dx, dy, dz, and you have to calculate d, of course. Okay, and then substitute f into the equation. You will get the final answer for FCD. Okay, from C to D. This is the answer of IJK. Okay, so this is the F, and for R, because I already mentioned that we have two different R, RAC and RAD. So basically, you have to determine both first. Okay, what value, what direction, what is the vector. Okay, so this is the thing that we do first. We state two different R first, then we have to choose letter. Okay, for the RAC, 2 plus 1.2, 2J plus 1.2K. Okay, RAC, okay, because we are only considering Y, this one. Oops. Okay, RAC, yeah. From here, here. Okay, so from here, there is only for Z component, which is 1.2K. Okay, 1.2K, and going up, consider Y component only. Okay, plus 2J. So that's why we get 2J plus 1.2K. Okay, for RAC. Okay, 2J plus 1.2K. So another R is from A to D. Okay, from here to here. Okay, so for this R, we only consider the Z component. Okay, this is RAD. So we only consider the Z component and also X component. Okay, so RAD. Okay, for the X component, okay, of course negative 0.4 I. Okay, and then for the Z component positive lah. Positive meaning that we have to add 1.2, add with 2.2, so we get 3.4K. Okay, let me check the answer. Is it correct? Yes. Minus 0.4 I plus 3.4K. All right. So once you have list down the value of R, then you can see that these two R only have two components. Okay, the first R is only Y component. This one is Z component. This one is X component. This one is Z component. So if you have the same component, I mean the number of component is same for both R, then you can use either one as you like. Okay, right? So the easiest, the simplest one is not there actually. Okay, it's not there actually. You can use either R. Okay, let's say we are choosing RAC. Okay, the first R, you have to substitute the RAC into the equation of moment. Okay, substitute RAC and FCD. Okay, then you have to cross it. Okay, you have to do the cross product. Okay, you will get the final answer of moment about point A, like this, the final answer. Okay, so you have to yeah, let's say we are doing we are applying determinant method. Okay, so I have to list down like this: I, J, K, I, J. Okay, so put you have to put, maybe you can put a table like this. Okay, to make it your work easier. F. Okay, so you have to put R value. For I, there is no I, 0. Okay, for RAC, okay. J, you have to put 2. K, you have to put 1.2, then repeat. Okay, and F, we do have as component 0.4. Sorry, this one is not the F. Okay, F, this one, negative 400, negative 2,000, 2,200. Oops, and repeat. Okay, and then you can do the cross product. Oops, you can do cross product. Okay, for the first one, this one. Okay, second one, this one. And the third one is this one. Okay, and then the negative sign should be like this. Okay, this one, and also this one. Okay, so you have to try it by your own, then you can see the solution. Okay, so you will get the answer like this. Okay, like this. Okay, right? Are you okay, guys?
Yes, doctor.
Yes, doctor.
Okay, so maybe I can give you some simple question to make sure that you understand about the solution, about this the choices of R. For example, let's say we do have this RAC. This is only example. Let's say we have 2I plus 3K, 3J, for example, plus 4K. Okay, and you have AD. Okay, this is only example. 6K, for example, plus 10Z. Okay, sorry. Okay, so my question is that if you have this R, these two R, which R you want to use for the calculation? AP?
RSC.
This one is AD. Okay, okay. Some of you are mention AD. Yes, the answer is correct. And can you state what is the reason why we have to choose AD?
Easier calculation.
Yes, the answer is easier. You will not, maybe you will not make any careless calculation. Okay, so you have to choose the simplest R. In this case, the simplest R is this one. Okay, because we do have only two components. Okay, we do have only two components. Sorry, this one should be J lah. Sorry, this is only example. Okay, so you have to choose the simplest one. Okay, but for the example one, because of the two are giving two components each, then you can choose either one. Okay, if you're choosing RD in your solution, the answer will be similar. Okay, you can try it by your own. If you choose RD to be put into your equation here, you will get the final answer like this as well. Okay, all right. So any questions so far? Any
Doctor, in
questions?
the previous slide, how did we get the 3?
3. Sorry,
Previous slide. This D.
D.
Yeah, how did we get that as 3?
This one is already teach last time. This 3, is it?
Yes, that one.
You have to use this formula. Do you still remember?
Okay. Yeah.
Okay. Any other question? No question. So if you see this final solution, maybe confusing, okay? As I mentioned, maybe you can just write like this. Where you put the final unit at the last one. Okay. You make it a bracket like this, and then you put unit n. Okay. Then I can understand. Sorry, it should be nm lah. Okay, nm. Okay. So basically, you have to put the unit for the final answer during the calculation here. Okay. If you don't want to put unit here, I think for me it is okay. Okay, no need to put unit every single things here. Okay, no need to unit for my case lah. For my marking. Okay, so you can ignore this one. Okay, you can ignore the unit here. You can, to avoid confusing. Okay, but I just want to remind you that the final answer should be including the unit lah. Okay, the final answer only. Okay, right. So the time now is 10:55. All right. Okay, so I make it quickly. Okay, the second question, you have to determine the shorter distance between point A and the line of action of the force. Okay, so the thing is that, yes, I mentioned just now, you have to find the shorter distance. Okay, so using the m equal to fd, the equation from 2D actually. Okay, but again, this is the vector product. Okay, not scalar product. You have to transform it into scalar product. Okay, so we do have this in vector product. Okay, but this one already give the scalar product. Okay, which is 3000. Okay, so in order to transform the vector product into the scalar product, you have to use this equation. Okay, substitute all the information in the equation, then you will get the MA. Okay, scalar product. Okay, and then substitute the value of MA into the equation here, and F is there already given in the question, 3000, and then you will get the shorter distance value, 2.288 meter. Okay, all right. So if you want to know where is the location of the shorter distance in 3D, it is very difficult, but I can show some illustration. So yeah. Okay. Okay, let's say this is the line of action. Okay, line of action, and this is the position where moment taking into consideration. So let's say I assuming the line of D, the shorter distance, is like this. Okay, and must be perpendicular to the line of action, and this is your shorter distance, for example. Okay, so in 3D we have difficulty to find to look at the shorter distance. We have to use maybe in terms of MATLAB. Okay, you can sort the distance, you can find the distance, shorter distance using MATLAB, using some algorithm. Okay, all right. So this is the thing that you have now. 2.288 meter. Okay, so now is 10:57. Okay, I think that's it for today. Is there any question?
Doctor, I would just want to ask that what is the final agreement for the test date?
What is the final agreement?
For the what did you agree about the test date? Which day is it?
Can you repeat your question, please?
When is the test for the date?
Okay. I thought date, kurma, date. So the date is already mentioned in the WhatsApp group. So I believe that
Yeah.
everyone agrees with that. Right. So if you have other option, then you can suggest. You have to suggest as soon as possible. But by default, the date as mentioned in the WhatsApp group. If you not you have
So
the objection.
the second message you send, yeah?
No, the first one that I sent to you.
The Friday one, yeah?
The Friday. Yeah. The Friday, I think.
Okay.
The Friday or Saturday. Let me check.
No, doctor, because we talked when, and we didn't say an exact date. You didn't finalize it.
Yeah, that's why I asked you in the WhatsApp group, if you have any objection, please do so. If no, then if yes, you have to suggest the date lah. Then we can consider. Okay. So for this date, actually we cannot discuss in the class because we will be taking long time to discuss. You can discuss it in the WhatsApp group.
Okay, doctor. Okay.
Okay.
Thank you.
For the class, better to discuss about the thing that we learn. Okay. All right. Before we end the class, is there any other question that related to the lecture?
No, doctor.
No. Okay. So if no question, I assume that you already understand the lecture. Okay. So you have to start with the practicing. Then you will know the difficulties and the problem that you face during the answering. Okay. So if no question, I think that's all for today. Thank you so very much. See you next week. Okay. So if you want to discuss something which is not related to lecture, you can discuss in the WhatsApp group as I mentioned just now. Okay. All right. Thank you so very much. Thank you and see you again.
Thank you, Doctor.
Thank you, doctor.
Thank you, Doctor.
Thank you, doctor.